Welcome back, Physical Science 20. This is the PW2 lab in which we're looking at images formed by a converging mirror. So we'll take a look at what you need to be able to do, and of course what for using an online simulation, we'll need to figure out where to find that, or if we're using the physical materials in the classroom, we need to know how to do that as well. So for this particular video, we're going to be looking at the online simulation. So the problems: what is the focal length of a converging mirror? What are the characteristics and locations of images formed by an object located at various positions from a converging mirror? And is the mirror equation 1 over f, 1 over the focal point, equal to the sum of 1 over the distance of the object and 1 over the image distance from the converging mirror? So materials, light source, optical bench, etc., etc. For using the online simulator, of course, we have all that information there. And backgrounds. You should look back in your notes, and you should be able to answer these types of questions here. So you would have done the plane mirror section already, and we could use a lot of those questions from there. Or you may have to read a little bit into the curved mirror reflection part, but you should be able to find it. So what image sizes are possible when bringing an image to the object producing the image? What is meant by image attitude? Okay, what does that mean? What image attitudes are possible when comparing an image to the object? Okay, so all that is from the plane mirror section. And what is meant by image type? What type of image? What do we mean by that? And then what types of images are possible when comparing an object to an image? So yes, actually you should be able to find all those from the plane mirror section that you just did, the PW2.4. Now, here, looking at this, it said if we were using physical materials, we would have to go through this procedure here to figure out the focal length of a particular mirror, kind of focusing the object, the rays coming from the object to see where they are focused, and that would help us find the focal point. But we will be using an online simulation, so we don't need to necessarily do that. So the place that we're going to look at, if we go to Google, as we'll see here in a second, what we're going to type in, ooh, that's too small, let's make it bigger. So we're going to look at, ooh, that's too big, physics, classroom, optical bench. So that's what we're going to be Google searching here in a bit. And so yeah, we can skip all of this, and whatever we have our simulation at, we'll write down the focal length, and then we'll place our object at these distances. So 2.5 times the focal length. So if the focal length was at 10, then we place this at 25. And then double the focal length, 1.5 times the focal length, at the focal length, and then half the focal length. And we'll be able to measure the image distance. It'll tell us. And then size, is it going to be larger or smaller? So we're always talking about in terms of in relation to the object. Is it going to be larger or smaller than the object? Attitude and type. Now I can't really talk about that because that's what you're supposed to look up, right? And then for just these ones here, 2.5, 2, and 1.5, I'm going to get you to figure out 1 over dou, so 1 over the distance of the object, and then 1 over die, and then figure out this here as well, the sum of these two numbers, and then also the magnification, which is taking the negative of the distance of the object, image, divided by the distance of the object, okay? So, and then for here, for these bottom parts, they're kind of unique, as you'll see. We won't have to figure out this blackened section here. We just need to figure out this. All right, so maybe what we'll do is let's look up this simulation. So physics, classroom, optical bench, you can see I already searched it. And here it is. It'll be the top item when you search physics, classroom, optical bench. Click on that. And launch interactive, it should work. It's not flashed as far as I know. If you click on this, we can make it smaller, I believe, or click on the bottom right. Yes, we can make it smaller. Oh, then it made it really small, so we can make it a little bit bigger there. There we go. Good. So first of all, Lenses and mirrors. Well, this lab is on mirrors, so we have to click this. So go, make sure you go to mirror, okay? And over here, the focal length that it's defaulted to be is 20 centimeters, which is okay, but we're going to have trouble making our object go at 2.5 times that. So here's the, we can pick a candle, we can pick an arrow, we can pick A, B, C, 1, 2, 3, you know me. But let's pick an arrow, because that's kind of what we're used to. Now, if oh, you can just grab the object and move it. So 20, 40, 60, I guess we could leave it at 20 if you wanted to, but we can't quite, let's see, 2.5 times 40, 50, I guess we could leave it at that. Or if you wanted to adjust the focal length, you could adjust it to wherever you want. See how the F is moving? And then, of course, the actual value will be over here. Now, the simulation is showing 3 principal rays, in through parallel, out through F. In through F, out parallel. It's also showing one going to the vertex, which is one I didn't really talk about. So if you want, you can click that off, and it makes the diagram less cluttered. It gives us the principal rays that we're going to be looking at in section 2.5. So again, we can move the arrow wherever we want for the most part. It kind of depends where you set up your focal point to be initially. And it's kind of touchy to move, like it's hard to get exact numbers here, but that's okay. We don't need to have it exactly 20 or exactly 30. We could have it at 28.8, or I recommend making it a little bit less than that, maybe even 13, 14, I'll leave it up to you, 16, 18, okay? So then we'll be moving this around, so here is twice the focal length, 2.5, you know where to go, inside, here. Ooh, so you saw a lot of things just with that right there. So anyway, you'll have all of the data that you need, object distance, object height, image distance, image height. You have all that information right there, folks. So when you go back to here, you'll be able to easily fill in this chart. We don't even need to have height here. And again, yes, for size, just put larger or smaller than. That kind of gives you a hint of what one of the answers is to one of the pre-lab questions, but that's all right. And then this, we won't have to worry about this either. We won't have to worry. Place S at 2. I guess we could look at this. We'll go in, but again, the simulator does all the stuff for you. This first page stuff. For sure, you don't have to do this part here because that is if we were using physical equipment. But yeah, you can read through here and make sure you answer it. But if you're filling in the chart, that is what the result of reading this would be. Okay? And then with that, you should be able to answer this. Describe how to find the focal length. Well, for that, we didn't actually do, but if you read through here, you will get an answer for that. And there's other questions here, other follow-up questions. There's a few calculation things over here, figuring out 1 over f and comparing it to this value that you did on the chart, because that's one of the objective is to see, does that mirror equation hold true? Is it valid? All right, so there we go. So that's how you do it using that online simulator. If you have any questions, feel free to ask, and hopefully I can help you out there. All right, see you again.